Good evening. Welcome, my dear J Warriors, class 11 syllabus. Continuing on full Josh, on full energy. And we are on to the vector multiplication today. And we're going to see the two most important ways of multiplying vectors, which is cross product and your dot product. So get ready for this energetic, lively, amazing class with your Captain Shreyas, your physics master teacher. I've been here doing this for the last 13 plus years, and I'm extremely proud of sending kids to their desired dream colleges. And of course, you are right now maybe in 11th standard and maybe some 12th standard students watching this for your backlogs. I'm pretty sure these lecture series are going to be very super duper helpful for your JEE preparation, because that's what students have been using so many years, and they come back to the channel and say, sir, I got into computer science, sir, I got into this branch, sir, I'm in this IIT, sir, I'm in this NIT, and I was watching your lecture series over here. So I'm really happy. Thank you so much for all your comments, and smash that like button in case you haven't done that yet, and subscribe to the channel. Okay, because you are going to be one of these toppers. Like this year we had all India rank 1 in ISI exam, which is the toughest exam in the country, even more than JEE Advance. It's for mathematical, sciences and computing and all of that. So all India rank 1, which came from ISI exam, and in JEE Advance we had all India rank 15, where students got really amazing scores even in other common entrance tests as well as Olympiads, right? So that's where I want you to be finally. Hi Vijit, Veva, Priya, Shravya, Sahita, Harshita, welcome. Taruna Priya, hi, good evening. Sir, I have Tamil exam tomorrow. Can I watch this as recorded? No issues. No issues, Abhijit. Yeah, no problem. Welcome. Good evening. Good evening. Yes, we have started the class. Now, we have seen that we have already seen that vectors, vectors can be added, added and subtracted, can be added and subtracted. Vectors can be added and subtracted. But division of vectors is something which you should never do. Division, division of vectors is illegal. Division of vectors is not defined. Division of vectors is definitely not defined. It's meaningless to divide two vectors with each other. Okay, so there is no such physical quantity in this universe which depends on the division of two vectors. Like velocity is displacement by time, time is scalar, numerator displacement is vector. Understand? Vector by vector, you will never see that. Okay, it's not allowed, it is illegal, it is not needed. You can multiply vectors, but division is not right. But multiplying vectors is allowed. So vector multiplication can happen in the following way. Vectors can be multiplied in the following ways. Vectors can be multiplied in the following ways. Like, for example, number one way, you take a vector 1, you take a vector 1 and multiplied by a scalar, multiplied by a scalar, the outcome will be another new vector, will be another vector. Or you take a vector, you take a vector and you multiply it with another vector. You can have, you can have, you can have, this is vector 1, this is vector 2, this is vector 1, this is vector number 2. The output can be a vector quantity or it can be a scalar quantity, depending on the symbol used over here. The output can be a vector quantity or it can be a scalar quantity, depending on the symbol being used over here. When you use a symbol like cross, when you use a symbol like cross, the outcome is a vector. This is also called as vector product. The symbol when I use as a dot, the outcome is a scalar, That is why it is called as a dot product. Sir, how do I know whether it is cross or dot, sir? Will somebody tell me? Well, it depends on the physical quantity. Like for example, quantities like work. Work is a scalar quantity. It depends on two vectors which can be multiplied with each other, like force and displacement. Force is a vector, displacement is a vector, but the outcome is a scalar. So whenever the physical quantity depends on two vectors, but the outcome is a scalar, then you will use dot product. But when a physical quantity depends on the multiplication of two vectors, but the outcome is a vector, then you will use the cross product. Like you will see something called as torque and angular momentum in rotation. It is a vector quantity and it depends on the multiplication of two other vectors. So it depends on the physical quantity whether you will use dot or whether you will use cross. Otherwise, mathematically, you give me two vectors, I can do dot multiplication or I can do cross multiplication. Is this absolutely clear, everyone? But vector multiplying with a scalar giving me another vector. Sir, what is that? Well, there are a lot of times you might have to multiply a vector with a scalar number, like a pure number, 2, 3, 500, whatever, minus 10, 0. And the result will be just a simple vector. That's it. So let's study all these three combinations. Is that fine? Everyone, let me start with the first one. Vector being multiplied by a scalar. Say for example, this is not needed now over here. Say for example, my dear students, I take a vector A, I take a vector A and I multiply it with a scalar like lambda. The outcome will be a vector quantity. What is lambda? Lambda is just a number, like a scalar number, like a scalar number. You can see I will get a new vector. What does this mean? Let's say for example, I have something like a vector over here, and I say that this vector is nothing but a bar. So what if I tell you how much will be 2 times, or let's say minus 3 times, or let's say uh, point uh, point 0.5 times of that particular vector. 2 times a bar minus 3 times a bar, 0.5 times a bar. What will these vectors look like? For example, let's start with the first one. 2 times a bar means you take a bar but increase its length 2 times. So the final vector will be like this in the same direction. That is basically your 2a bar. Same thing, but 2 times. What is minus 3a bar? Forget the negative sign. 3 means you take a 3 times. And negative means you change the direction. So most likely it will be something like this. This is negative 3a bar. Everybody getting it? Similarly, 0.5 a bar. That means whatever the length is, half of it. So just this much in that direction. So that is basically your 0.5 a bar. So when you multiply a vector with a number like this, minus 100, 0.1, anything, you will get a new vector which is either in the same direction or in the opposite direction. But sir, what if I multiply it with the number 0, sir? What if I take 0 times of a bar, sir? Can you guys quickly guess and tell me what will be the final answer? 0 times a bar will be nothing but a null vector. Will be nothing but a null vector. You are multiplying it with 0. That means you are vanishing it. You are completely, removing it from existence. Yeah. I hope this is clear. If a vector is multiplied by an imaginary number, that will be crazy. Something, it is talking about an imaginary space which cannot be shown in this real space. To do that, I mean, you can do it for the heck of it, but it will not mean anything in this real space. Okay. So whenever you multiply a vector with a scalar number, okay, such a multiplication is just called as scalar multiplication. Scalar multiplication. Scalar multiplication. Then I can say that this particular vector B is in the same or opposite direction, same or opposite direction of a vector. It is in the same direction or opposite direction of a bar, unless 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 there is a special scenario, unless lambda is 0, then 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 b vector is nothing but a null vector. Then b vector is nothing but a null vector. So as long as this is some number like 3, 500, whatever, it will be either in the same direction or in the opposite direction. If it is positive, then it is same direction. It is obvious. The answer will be same if lambda is positive, if lambda is nothing but a positive number, and it will be in the opposite direction, if lambda is a negative number. It kind of makes sense. Negative means opposite direction, positive means same direction. Is this absolutely clear, everyone? What is the meaning of the term scalar multiplication? Taking a scalar multiplying by a vector gives me another vector over here. That is nothing but called as scalar multiplication. That is called as scalar multiplication. Give me a thumbs up or put a fire emoji in the chat box. Very good, Priya. Clear. Rama, I hope this is clear. Yes, Priya. Everyone. Harshita, Raj, Tharuna, everyone. Shravya, Veva. Okay, perfecto. Let's go ahead. Awesome. Now that we are clear about what this is, let's talk about these two. Now, whenever these two are being spoken about, please remember one thing. These two are usually called as, products. These are vector and scalar products, whereas this is called vector multiplication. I know they sound similar, So this one is basically called multiplication of a vector, scalar multiplication, okay, of a vector. But these two are generally called vector product or scalar product. Please understand that. So this is just a vector product. These are just products, vector products or scalar products. This particular operation, the first operation, is called as a scalar multiplication. So you should know these terms. You should just know these terms, just in case when they are used in mathematics. So let's start seeing one by one, and let's start with the easier one, which is basically the scalar product. Scalar product, or I can call it dot product. Dot product. Dot product. Examples, let's start with first. Let's start with examples and then we will go ahead. Say, for example, we have a vector quantity like force and you have displacement which is multiplied with it. The outcome of this is nothing but work, which is scalar quantity. Or you have force and you multiply it with velocity, which is also a vector quantity. The outcome is a scalar quantity, which is nothing but power, Later on, you will also see things like electric field or magnetic field multiplied by something called as an area vector. That will give you something called as flux, which is a scalar quantity. All right. So there are many such things in physics who are all scalars as an outcome, but it's the multiplication of two vectors. It's a multiplication of two vectors. Vector 1 with vector 2 is a scalar quantity. The symbol that I use will be a dot symbol. That's why it is also called dot product. Since the outcome is a scalar, that is why it is also referred to as scalar product. Okay, so vector 1 into vector 2 dot producted is a scalar. So technically speaking, these are all vectors over here. When I put a bar, I will put dot to signify that the outcome is a scalar quantity. These are some live examples where you use directly in physics dot product or scalar product. How do I know what is the value or how do I perform this operation? The manner in which you perform this particular operation, it is as follows. Observe it carefully. Okay, how do you perform the dot product? So you have one vector here, another vector over here. I want to know the dot product of them. So if I do A vector dot producted with B vector, the outcome is take the magnitude of the first vector, take the magnitude of the second vector and multiply it with cos of the angle between the two vectors. So theta is the angle between them, is the angle between A vector and B vector. Then you will get the dot product of those two vectors. That's how simply it has been defined. A dot B is nothing but AB cos of theta. A dot B is nothing but AB cos of theta. So let's have a look at some examples to understand it and the properties, of course. So starting off with some properties. If I do A dot B, if I do A dot B, if I do A dot B, okay, if I do A dot B, second, yeah, if I do A dot B, the answer will be magnitude of A, magnitude of B into cos of theta. If I do B vector dot A vector, it will be B into A into cos theta. The answer is the same. The answer is the same whether you multiply 5 into 3 or 3 into 5. It's the same thing. These are magnitudes. So therefore, one can easily conclude A dot B is nothing but B vector dot A vector. So what does this mean? If B dot A is A dot B, it means that it is not dependent on the order, and when the outcome does not depend on the order of the events, then such a thing is called as commutativeness. So it's commutative in nature. It is commutative in nature. Okay? All right. Sir, what is the scalar product more than two vectors? Rama, will come to that. Triple product it is called. Okay, you can also do triple product. We'll come to it in a bit. Next important property of a dot product is that if I do A vector dot B vector plus C vector, so I'm adding two vectors and the result I'm dot producting it with another vector. Then you can do one thing. You can take the dot product of A with B and A with C individually and then add them. So whether you add first and then multiply, or then you multiply and then add, irrelevant. So B plus C, I can open up the brackets and multiply it individually. This particular property is called as distributive property. I can distribute it. Distributive property. It is distributive in nature. I can distribute this A with B also and C also. That is why distributive in nature. Is that clear? So these are two major properties that you should definitely know about the dot product. Now let's take some specific examples for dot product and also see how does it come out to be. Say for example, somebody decides, okay, I want to take the dot product of A vector with the vector A itself. Wow. What is the meaning of taking the dot product of A with vector A itself? It means I'm taking the magnitude of A, I'm taking the magnitude of A again, and I'm multiplying with cos of the angle between them. What's the cos of the angle between them? Both similar vectors, they are parallel to each other, they will have no angle. That means cos of 0 degrees. So therefore, it will be nothing but A into A cos 0 is nothing but 1. So this is as good as saying it is A square. So A dot A is A square. As simple as that. Then I have an idea. Sir, what if it was A hat dot A hat? Well, it will be magnitude of A hat into magnitude of A hat into cos of 0, because A hat and A hat will be parallel. Angle will be 0. Magnitude of an unit vector is 1. Magnitude of an unit vector is 1. Cos 0 is 1. So it will be 100% 1. So A hat dot A hat will be 1. Oh, so then what if I do I hat dot I hat? Or what if I do j hat dot j hat, or what if I do k hat dot k hat? All of them are unit vectors dot producted with themselves. They will always be 1. I dot I, j dot j, or k dot k will be exactly equal to 1. Everyone, hi Anushka, good evening. Yeah, perfecto, clear. Right. Wow, this is amazing, sir. Great. Sir, what if I take two perpendicular vectors, sir? Let's take that example. If A vector is perpendicular to B vector, then then if you take the dot product of A dot B, then it will be magnitude of vector A, magnitude of vector B into cos of 90. Wait a minute, what is cos of 90 degrees? Cos 90 is 0, so the outcome will be 0. So therefore, A dot B is 0. This in fact is then called as the perpendicularity test. This is called as perpendicularity test, which means if the dot product of two vectors is 0, then the vectors must be perpendicular. This is very, very important. If the dot product, if the dot product of two vectors, is 0, then they must be perpendicular. They must be perpendicular. The converse is also true. If two vectors are perpendicular, then the dot product is 0. Okay, so the actual statement can be if the dot product is 0, they are perpendicular, or the vectors are perpendicular, then the dot product is 0. So this brings me to the notice of I cap with j cap. I is in x, j is in y, they are mutually perpendicular, or even j with k, or even k with I. It doesn't matter. I dot k, k dot I, j dot k, k dot j, j dot I dot j. All of them are perpendicular. The answer will be definitely a null vector. Or not null vector, it will be 0. It's a scalar number, 0. Is this absolutely clear? I dot I, j dot j, sorry, I dot j, j dot k, k dot I. All these things are perpendicular. So 100% the answer must be a 0 number. Okay. So what it means in real is basically exactly this. When you are performing the dot product, it means you are making a system of rules, okay, which has to be followed by looking at these physical quantities. They see dot product did not come first. These quantities came. Scientists realized, oh, every time there is a vector multiplied by vector, and always the final answer is this magnitude into cos of angle between them. So because every time it is getting repeated in physics, many places, many physical quantities, so they thought, why not make it as a rule? So they made their own symbol. Tomorrow, you can also make, sir, I saw there are 7 physical quantities or 20 physical quantities which follow this rule, sir. It is vector 1, uh, and if I take another vector and then I have to take the square of it and I have to divide it like this, or maybe, I have to take some cos of angle between them and I have to divide it with, I don't know, 1 plus e raised to theta, sir. I'm seeing this is happening every time. I'm seeing that is the final answer every time. Then you can give your own symbol. Vector 1, my symbol is like this. Into vector 2. This symbol means you have to take first vector, second vector square, cos theta upon 1 plus e raised to theta. Because it is happening many times, you symbolize it. So scientists saw many physical quantities following the trends every time. So they gave a symbol like dot and cross. That's all. That's what dot and cross product is. It's just a symbol to operate between two vectors. Just look at it like that. So dot product didn't come first. It was the other way around. The quantities came first, and then people understood how to deal with it. Okay, sir. Understood. Now, what if I had to give you some examples of this? Okay. Let's start with some examples. I cap dot 4 j cap. What is the answer? Minus 3 j cap dot 2 k cap. What is the answer? Then minus, or let's say 2 I cap dot 5 I cap. What is the answer? Minus 3 j cap dot 2 j cap. What is the answer? Minus k cap dot minus 7 k cap. What is the answer? Come on, think about it. Then we'll go ahead. Okay. Yeah. What do you think are the answers for each one of them? Starting off with the first one, I and j are perpendicular. 100% the answer is 0. J and k are perpendicular. Answer is 0. Whenever vectors are perpendicular, the outcome will be 0. That's what I just told you over here. Okay. I into I is 1. So 2 into 5 is basically 10. That's it. 2 into 5, 10. I dot I is 1. Remember that. Minus 3 and 2 will give me minus 6. J dot J was 1. So J is 1. Keep that in mind. K is 1. Minus minus is positive. So it will be nothing but minus 1 multiplied by minus 7, which is as good as saying it is plus 7. Very good. That's how you multiply these vectors. Sir, what if it is slightly more complicated? Yes, why not? Let's take more examples. Say it is I cap dot 2 j cap plus k cap. Then what is the answer? Let's say it is 2 I cap dot 3 I cap minus k cap. Then what is the answer? Let's say it is 3 j cap dot minus 2 j cap plus 5 k cap. Then what is the answer? What if it is 2 I cap plus 3 j cap dot producted with 3 I cap minus 4 j cap? Then what is the answer? What if it is minus I cap plus k cap dot producted with 3, or let's say 5 I cap plus 7 j cap? Then what is the answer? Let's try to do it in every situation. Starting off with the first case, here I can open up the brackets, so it will be technically I dot 2j plus I dot k cap. I and j are perpendicular, so answer is 0. I and k are also perpendicular, answer is 0. So the final answer is 0. Right, perfect. What about this? So this will be, open up the brackets, 2I dot 3I plus 2I cap dot minus k cap. I and I is 1, 2 3s are 6. I and k are perpendicular, so answer is 0. So the answer will be 6. Okay, I dot k will be 0 because they are perpendicular. What about this? J and j will go, so it will be 3 multiplied by minus 2 plus, this will be nothing but j into k, which is 0. K and j are perpendicular, so the answer will be 0. So it will be nothing but minus 6. Is that right? Very good. Many of you got it correctly. I can see that. Very good, Rama. Very good, Togo. Very good, Taruna. Awesome. Perfect. What about this? Okay, there will be many terms when you open up the brackets. Like, for example, you will have 2 I cap dot 3 I cap plus 2 I cap dot minus 4 j cap plus 3 j cap dot 3 I cap minus 3 j cap dot 4 j cap. So when you solve this, okay, 2I into 3I is basically 6. I into j is 0. J into I is also 0. 3 4s are 12, so minus 12. So 6 minus 12 means minus 6. Just check it out. Answer will be minus 6 again. Very good. Excelente. Very good, Togo. Yep, perfecto. What about this? Again, multiply. Open up the brackets. So minus I cap dot 5 I cap minus I cap dot 7 j cap plus k cap dot 5 I cap, k into 5 and k into 7j. So k cap into basically 7 j cap. Okay, so what is it going to be? I into I is 1, so this will be minus 5. I into j is 0. K into I is also 0. and k into j is also 0. So the answer will be minus 5. So the answer will be minus 5. Just check it out. Yep. Is this absolutely clear? Let me know, guys, quickly in the chat box. Quickly in the chat box. Is this absolutely clear? Yeah. So only one term was getting multiplied. Rest everything is 0. Perfect. Mabita, yes, definitely, man. I have a batch where I'm teaching. You can just check it out. The description box has it already. So as you're watching this particular video, you go down to something called as the Sigma batch. Yeah, Sigma batch, which is there right over here. Where is it? Yeah, Sigma batch for 2026. Entire 11th and 12th standard portions are there. Okay. But it's not me who is teaching everything. There is another teacher called as PNJ sir who is teaching you physics. But whether it is this batch or even the pro batches, all the students. So if you are looking for a 2-year batch, then you have the pro batch. You will find all my content where I have taught the entire physics in VBuddy. So the entire access is given to you. Okay, whether it is pro batch, whether it is Sigma batch. So you are getting the complete video library, which is entire 11th and 12th portion taught by me. Okay, so you will get access to it. The links are there in the description box. Okay. Okay. All right. All right. Last one is not 0. Last one is not 0. Why not? It's k dot j, man. K and j are perpendicular. Huh? K and j. This is not j and j. Be careful. This is k cap and this is j cap. Okay. Yeah. Is that okay, Togo? Sir, why we need vectors and their properties while we also know geometry? Sometimes solving by vectors is much easier than using geometrical properties. In fact, you will see in mathematics as you progress ahead, many questions can be easily solved by vectors by notation of ijk rather than using geometry. Oh, there is a line going this way, the normal is like that, the tangent is like that. You show it in a vector equation, it becomes much easier in certain cases. In certain cases, geometry is easier. So mathematics, why are there so many chapters? Can't we just have one chapter in maths? No, there are different problems need different methods of solution. That's why there is no one solution to everything, isn't it? Yeah. Thank you so much, Taruna. Right. Okay, batches are lagging and here you are getting conceptual clarity. I'm so happy. K and 7K. Where is K and 7K? There is no K and 7K. This is K and this is J. Huh? I think you guys are confusing between the symbols. This is IJ, KI, KJ. Okay. I cap will multiply. I cap and J cap will not multiply. 0. K and I, 0. K and J will also not multiply. Okay. So I think some of you are reading the symbol wrong. Maybe my handwriting is not that great. Okay. Maybe you can open up any of the links. The fees will be there as much as it is. I'm so glad, Tollywood, you're loving the lectures. Thank you so much. Thank you so much. Okay. Sir, take some more complex questions, sir. Okay, fine, my dear. What if it is 2i cap plus 3j cap plus 4k cap dot I cap plus 5j cap plus 2k cap? Oh my God. Now so many terms will come. Start off individually. So you will have 2 I cap multiplying with I cap. Then you will have 2 I cap multiplying with J cap. Then you will have 2 I cap multiplying it with 2K cap. Okay. So this with this, and this with this. Then 3J with all of them. So 3J cap dot I cap plus 3J cap dot 5J cap plus 3J cap dot 2K cap. Okay. Then last one, this with this with this. So 4K cap dot I cap plus 4K cap dot 5J cap plus 4K cap dot 2K cap. But I'll tell you what, many of these are utter nonsense. Like I into J doesn't matter. I into K, 0. J into I, 0. J into K, 0. K into I, 0. K into J, also 0. What remains is only this one, and this one. So 2i into I is basically 2 because I into I is 1. JJ is 1. 3 5s are 15. 4 2s are 8 because k into k is 1. So 8 plus 2, 10. So this is nothing but 25. What is that interesting thing that you saw? Whenever you have a big term like this, I will go with I, J will multiply with J, K will multiply with K. Anything else will be 0. Correct. So if tomorrow you are getting a question like this, listen, force is minus I cap plus 7J cap minus 2K cap Newton, and my displacement vector is 2I cap plus 3K cap plus 5K cap meter. Then if the question is, can you find out the work? I'll be like, yes, why not? Work is nothing but force vector dot producted with the displacement vector by definition. If you have not yet read work chapter, don't worry, just take it as a rule that, okay, I know it already, or just take it as a assumption or the truth. What will you do? I will multiply with I, so it will be basically minus 1 multiplied by 2. J will multiply with, sorry, I wrote K cap over here, my bad. This should be 3J cap. Yeah. J will multiply with J only, so it will be nothing but 7 multiplied by 3. Lastly, you will have minus 2 multiplied by 5. Anything else cannot multiply, the answer will be 0. So this will be minus 2 plus 21 minus 10. So this will be nothing but minus 10 minus 2 is minus 12. So 21 minus 12, that's going to be 9. So 9 joules is the answer. 9 joules is the answer. Got it? Very good. Many of you understood. So the final, thing is where you can write that if you have A vector dot B vector, where your A vector is some X component, Y component, and Z component like this, and your B vector is X component of B, Y component of B, and Z component of B, then the final outcome is AX BX plus AY BY plus AZ BZ. X with X, Y with Y, Z with Z. That's it. That is your final result that you should get. So you can multiply any big vectors now by using this logic, like I've shown over here. Okay? X with X, Y with Y, Z with Z. Is it absolutely clear? Now, guess what? Vector multiplication can also be used to figure out the angle between the two vectors. Yes, you heard it right. To find the angle between the two vectors. How, sir? See, A dot B was AB cos theta. Just take it below. So what is cos theta? Cos theta is A bar dot B bar by A multiplied by B. So therefore, theta can be found. Theta is cos inverse. You first find A dot B separately, and in bottom you multiply the magnitudes of A and B. So understand the difference. A lot of people think, say, sir, A into B, A into B, sir, AB and AB will cancel, sir, cos inverse of 1, sir. Cos inverse of 1 is, sir, 90 degree, 0 degrees, sir. Is that the answer? No, 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 you cannot do that. See, this is dot product of vectors. This is just simple multiplication of scalars. So on the top, this is nothing but like saying AX, BX plus AY, BY Is it audible now? Is it audible now? Yeah. Sir, whole question you are muted only. Oh my God. Now, okay, but were you seeing the solution? I'll just explain the solution once more. Okay, let's assume this is vector A. Let's assume this is vector B. So to find the angle between the two vectors, I need A dot B, A and B separately their magnitudes. Okay. Now magnitude of A means this square, this is square under the root, which is root 6. Magnitude of B means 2 square, then 1 square, and then this 1 square, which is also root 6. A dot B means AX BX, which is 1 into 2. AY BY, which is 2 into minus 1. And AZ BZ means minus 1 into minus 1 over here. This is 2, this is minus 2, this is plus 1. This cancelled, 1 will come. So cos theta is A dot B by AB. So A dot B, we figured it out from here. A is nothing but root 6, B is also root 6. So root 6 into root 6 is 6. So theta will be cos inverse of 1 by 6. Options will also be like that only in the exam. Cos inverse root 6, cos inverse 1 by root 6, cos inverse 6, cos inverse 1 by 6. So wherever it says cos inverse 1 by 6, you will mark it. Okay? Right. Hello, welcome, Sravanan. And yeah, sir, I'm feeling guilty. I can't attend. No issues, Abhijit. Don't feel guilty. Just watch it after some time. Okay, when your Tamil exam is over. Yeah. And Sravanan, you should have come. No, I was in Chennai yesterday. See how drained out I am. Whole night I was traveling. Whole 2 nights gone. Yeah, you should have come. A lot of amazing students came, and I was also hoping some of you guys will also be there. Wonderful interacting with all of you guys. Sir, any trick to find it easy and fast? Just dot product is very easy, man. Like this doesn't take much time. It is just that I'm explaining it for the first time over here for you guys. So it feels first time whenever you see a problem, it is lengthy, but actually it is not. Okay. So let's do some questions now. Let theta between the angle between the two vectors, then cos theta is equal to how much? Well, cos theta. What is cos theta? A dot B by A into B. So A dot B means 1 into 1, which is 1, plus 3 into minus 3, which is minus 9, 7 into 7, right, which is nothing but 49, upon what is the magnitude of this guy? Check it out. It will be root of 1 square plus 3 square plus 7 square into, again, 1 square plus 3 square plus 7 square for the vector B. Okay, everyone? So 49 minus 9 is 40. So that will be nothing but 41 on the numerator side. Here, what are you going to get, guys? Come on, guys. What are you going to get over here? What are you going to get? 49 plus 1, 50. 3 square is 9. So this will be 59. This is also 59. So technically, this is 41 by 59. 41 by 59 is option A, of course. Very good, Rama. All right. Very good, Togo. Very good, Vivadi. Paki, welcome back. Yes. Oh, yes, it was too powerful, Abhijit. Too good. I really loved the, that vibe is only different. And Shimon sir was also there with me. That connect. And Shimon sir was talking in Tamil, and I was here explaining all the kids out there. Students were very motivated, very energetic. Majorly NEET students had come. It was not a JEE event as such, but we should have a JEE event very soon. Yeah. So was wonderful interacting with my fellow mates, and especially considering the fact that I was born in Tamil Nadu in Salem, going back to my birthplace, not exactly the same city, but the birth state, that vibe, that feeling is always, very, very different. Yeah, correct. So moving on to the next question, my dear warriors. A particle under the constant force ij minus 2k gets displaced from one point to the other. Find the work done by it. So if you go from this point to this point, displacement will be, remember, always take final coordinate minus initial coordinate and respective I cap, J cap and K cap. Yeah. So what is this? This will be 4 minus 2 final minus initial I cap. Similarly, final minus initial, that means 3 minus minus 1 J cap, and lastly 2 minus 3. So final minus initial K cap. So this will become nothing but 2 I cap, 3 minus minus is plus, so 4 J cap, and lastly 2 minus 3 means minus 1 K cap. So that is the displacement in meters. So the question says find the work done. Work done is force dot displacement. Force is I cap plus J cap minus 2K cap. Dot with displacement means 2 I cap plus 4 J cap minus K cap. So this will become 1 into 2 is 2. J into 4J is 4. Minus minus is plus. So 2 into 1 is 2. So this will be nothing but 8 joules. So 8, not Newton, it will be joules. Sorry, the units are wrongly mentioned over here. I need to correct it. So it will be 8 joules. It will be 8 joules. Correct. 8 joules will be the answer. Absolutely clear, my dear warriors. Perfect. This is how you can do it. Very good, Vivadi. Very good, Togo. Very good, Thanura. Awesome. Perfect. Slowly, you guys are getting the hang of dot product. Moving on to another question coming up on your screen. Okay. These two vectors are perpendicular to each other. Then what is the value of m? I just gave you something called as the perpendicularity test. If their vectors are perpendicular, then their dot product is 0. So that means you take I cap plus 2m j cap plus m k cap dot producted with 4 I cap minus 2 j cap, minus 2 j cap plus m k cap. The answer will be 0. Needless to say that I have to multiply I with I, J with J, and K with K whenever I do dot product. Okay. So 1 into 4 is 4. 2m into minus 2. So it will be 2m into minus 2 over here. And lastly, m multiplied by m should be 0. So therefore, 4 minus 4m, yeah, 4, right, minus 4m plus basically m square is equal to 0 plus m square. M into m is m square. So what is this equation, guys? It's very simple. It is m minus 2 whole square is 0. This is the expansion of m minus 2 whole square, a minus b whole square, a square plus b square minus 2ab. So therefore 100% m minus 2 will be 0. Therefore 100% m will be 2. So which is option number C. So that's how you have found out the unknown. This was a JEE question asked in 2023. Yeah, this kind of questions can also come in your JEE entrance exam. Perpendicularity test. Whenever two vectors are perpendicular, the dot product is 0. If dot product is 0, the vectors are perpendicular. Perfect. Okay. Okay. My God. How you people find the answer this fast? Don't get scared. Some people might have studied this topic before only. Some people might be just genuinely fast. Some people might take time to understand it first time, but eventually the speed comes up. Everybody's learning curves are different. But when you give enough time, because you're in 11th or 12th and you study this properly for 1 year or 2 years, eventually with enough practice, you can reach, a good level. Okay. Some people might genuinely be very fast. So, don't compare yourself so much. Okay. Don't get disheartened. Try your best. Eventually, you will get there. Yeah. Vector projection. This is also a very important application of dot product. Vector projection means finding the projection of a vector on another vector, or finding the shadow of a vector on another vector, or finding the component of a vector on another vector. So vector projection, or basically finding the shadow, or finding the component. See, I'll tell you, for example, For example, if there is a vector, let's say v bar, when I say Vx, it means the x component of V. And what is the meaning of x component of that vector? It means that I have a vector V and then you have some line which you have called as the x-axis. You take the shadow or the projection, meaning you draw a line perpendicular to the x-axis. You draw a line perpendicular to the x-axis and then you measure how much a vector v is there along x. That is your vx. This is also the shadow of v. Imagine light rays were coming from the top, this much will be the shadow. This is also the projection. That means if light was projected from the top along the yellow dotted line, this much will be the length of that shadow or the projection. It's also the component of that vector along that axis. That's how I write any vector. Similarly, just think now, if I say that I have a vector a bar, if I have a vector a bar and I write AB, A subscript B means what is the shadow or projection or the component of vector A along the vector B. Vector A along B, just like what is the x component of B or how much is the vector component along the x direction. Same way, AB means A of B means how much is A along any direction, along any random direction. So again, you draw a dotted line which is basically perpendicular, to the line along which you want to find the component. So naturally, this much will be nothing but A of B, which is what you need. That is nothing but A of B. Everybody understanding the meaning of this word? Yeah? Everybody understanding the meaning of this word? AB. What if it was BA? What if it was, for example, it was BA. It means component of B along A. Meaning you take B and you drop a perpendicular on this line. So this particular length will be B of A. So whichever line along which you are finding the component, you drop a perpendicular on that. That is what it means. Absolutely clear, everyone? AB and BA are totally two different things. It's not the same magnitude or same direction. Yeah, they're two completely different things. How do I find out the value of them? It's simple. See, if you look at the triangle over there, cos theta, which is adjacent side, which is AB, divided by hypotenuse having the length A. So wait a minute, cos theta I already know. Cos theta is nothing but A vector dot B vector divided by magnitude of A and magnitude of B. So that is AB divided by A. What happens now is that this A and this A just got cancelled off. Yeah, this A and this A just got cancelled off. So therefore, A of B is nothing but A dot B divided by B. But I'm not so happy about it. So I'll do one thing. I will just write it down as, therefore AB is A vector dot B vector divided by B. So I put that denominator only under B, which is fair, nothing wrong in it. What is this exactly? How many of you remember? What is a vector divided by its magnitude? So B bar by B is nothing but B hat. B bar by B is nothing but B hat. So therefore, I can just say A of B is A bar dot B hat. So that's it. That is the answer, guys. So if you remember this, your job is done. So component of a vector along another vector is the vector dot producted with the unit vector along which you want to find the component. Unit vector along which You want to find the component. Yes, perfect. Okay, so we've used the fact that b hat is vector b divided by vector b, its magnitude. So let me give you an example of this particular thing. Find the projection of this along this, which is a random direction, and this was asked in JEE, okay, a couple of years back. So to find that out, I will first say whose component do I need along whose component. Projection of A along B means I want to find AB, which is A bar dot B hat. So first let me find what is B hat. Okay, let me find what is B hat. So B hat will be vector B divided by its magnitude. Vector B is I cap plus J cap. Magnitude of that will be 1 square plus 1 square under the root. So it will be I cap plus I cap plus J cap, whole thing divided by root 2. That is your B hat. Okay, so I'll put dot product over here. I'll put I cap plus J cap over here, and I will put root 2 over here. Lastly, what is A vector? A vector is nothing but I cap plus J cap plus K cap. Okay, and that is dot producted as it is. So I will multiply with I into I is 1 into 1 plus J into J means 1 into 1. K has nothing to multiply, so 1 into 0, that's it. Whole thing divided by root 2. This is 1 plus 1, which is 2, divided by root 2, which is simply root 2. So magnitude wise, it is root 2. So magnitude wise, it is 100%. How much? Root 2. Till this point, absolutely clear. Magnitude wise, it is root 2. Okay. But the problem is they have not asked the length, they have asked the vector itself. They have not just asked the length, but they have asked the vector itself. If you are little bit smart also, you can quickly eliminate the options from here and see which of these vectors has magnitude of root 2. If you see the first vector, 100% it is like 1 square plus 1 square plus 1 square, 1 square plus 1 square plus 1 square multiplied by root 2. 100% is not root 2. In fact, it will be nothing but root 2 multiplied by root 3, which is root 6. So definitely magnitude wise it is not root 2. So A option gets eliminated. This also you can eliminate. Even this also you can eliminate. C can't be root 2. This also can't be root 2. But if you take the magnitude of this guy, it will be root of 1 square plus 1 square, which is basically root 2. So answer will be B. Answer will be B, and you can check it out over here. Yes, perfectly. The answer is B. So that smartness has to be used. But sir, you just got lucky, sir. What if there were two options? What if there were two options? One option said I plus J, another option said I minus J. Then how will you do it, sir? Correct. You are very right. Then I have to teach you the method. Obviously, I cannot say you have to eliminate options. Then I will not be considered a good teacher if I always do by elimination by options. So how to do it during that case? I know one thing. A of B is component of A along B, that is also along B hat. AB is component of A along B, but B and B hat are same direction only. So whether you find A along B or you find A along B hat, it's one and the same thing at the end of the day. Okay. So then what is your point, sir? Can I then say my vector AB will be magnitude of that vector times the unit vector over here, times the unit vector over here. Any vector you see will be magnitude times the unit vector. In fact, unit vector was vector divided by that magnitude, if you remember carefully. So, A hat B was A bar B divided by AB divided by A of B. This technically is nothing but B hat. How many of you understood this? How many of you understood this? This is my vector, let's say A. Let's say this is my vector B bar, B hat will be something like this. This will be nothing but B hat. This will be nothing but my A vector. So the component means I drop a perpendicular over here. So then if I show this vector, this much is nothing but A of B lengthwise, but vector wise, I'll show it with the direction. So how many of you understood a unit vector along A, B is the same as unit vector of B itself? How many of you got this? How many of you understood this? Because direction is the same. Even if I take another weird vector, long vector C bar, C hat will be exactly this. C hat will be exactly this. So technically, even this much is also A hat of B only, which is also the same as saying this is B hat. Everybody gets this. A unit length in that direction will always be the same in length. Yeah. All right. Pranav coming soon. Coming soon. I think July 17th or something. My lectures are scheduled already. Yeah. Everybody fine? Why this is true? Okay, sir. Sir, but what is this? This is exactly what you have to find. And this number you just multiply over here, A of B. This is now scalar. This is now a scalar multiplied by a vector giving you another vector, which is perfectly feasible. It is allowed. And this value, we just got it as root 2. This is nothing but root 2. What is B hat? B hat, we found it over here, which is nothing but I cap plus J cap by root 2. So that is nothing but our vector itself. Therefore, our vector is root 2 cancels, will be I cap plus J cap, which is option B, of course. This is how you can find the vector itself. But if the length is asked, then the solution would have ended in the last slide, which is just root 2. Clear, everyone? Okay. What is the use of projection of vectors? Very valid question. Where do you use projection of vectors? See, the concept of projection of vectors is used many times in kinematics also. For example, what is the acceleration along the velocity? What is the acceleration along velocity? That means acceleration along velocity. That is how this is. This is also called as sometimes the tangential acceleration. Tangential acceleration. Yes. So this is one such application. This is one such application. And there are many such applications where you have to find some physical quantity along some other physical quantity. Okay. So that's how you can use the concept of projection. Clear? So circular motion, rotational motion, even in field, flux, so many places you might use this concept. Force, what is the direction of, or what is the magnitude of the force along the displacement? Maybe I need it somewhere. Yeah. Great. Perfect. Now, let's go to the next concept, which is nothing but the cross product. Cross product. Dot product done. Now let's go to the cross product. Cross product means that multiplication of two vectors should give me another vector. But the moment this comes, two questions come to my mind. First question that comes to my mind, what is the magnitude? What is it defined as? Second question that comes to my mind, what is the direction, sir, of the third vector? Okay, which is the multiplication of two vectors. Fine. So I take a vector A, I take a vector B, and I multiply both of them. I multiply both of them to get another vector. Examples, like I take force and I take position and I multiply them. Or I take position and I take momentum and I multiply them. All right. Or let's say you take something like, you know, velocity and you multiply it with magnetic field with the charge. You will see the outcome of this is a new vector, which is like torque. Here it is angular momentum. Here this is the force on a charge due to magnetic field. every time there are certain observations which were made and some peculiar pattern was followed. They saw that every time you multiplied two vectors where the outcome was a vector, the magnitude of that vector, which came, that is C, magnitude of that vector which came, which is C, always was first vector's magnitude, second vector's magnitude into sine of the angle between them. Not cos, it was sine. Everywhere that was the common trait which was found. So they thought, instead of mentioning it again and again, let's define a symbol, an operator, which is called as a cross operator between the two vectors. So every time I put a cross, it is understood that the magnitude will be first vector, second vector magnitude into sine theta. Okay, that is first thing. So when I say A cross B is C, that means the magnitude of the vectors is nothing but each individual's magnitudes into sine theta. That is the first thing which you get. The next thing is the direction. So this was magnitude. This was magnitude. Okay. But what about the direction? Now, this direction is a very special thing. It is given by something called as the right hand thumb rule. Right hand thumb rule. Take the right hand. Take your right hand. Take the four fingers except the thumb, the four fingers over here, and let them point to the first vector. So let's say my first vector being A, let's say my first vector being A, it is over here. Okay, this is my first vector, which is A. And the fingers of my right hand should point exactly in that direction. Okay, this is my right hand. I'm showing like this. Slowly bend the four fingers towards B vector. So maybe that B vector is over here. So that B vector, if it is here, these fingers will slowly bend like this. They will bend like that. Are you able to visualize this? They'll bend like that. Automatically, the thumb will point in a very unique direction. In this case, the thumb will be like that. This is my thumb. Wherever the thumb points, that is the direction of A cross B. That is the direction of A vector cross producted with B vector. That is A cross B direction or C vector's direction. Always choose the four fingers in the direction of the first vector, then the second vector, they should bend towards it. Automatically, that thumb will point in the direction of A cross B. That is your right hand thumb rule. Also note that our final resultant which is there, which is our vector C vector, or I can say A cross B vector, is perpendicular to both vector A also and vector B also. That is very, very important. C vector is perpendicular to A also and B also. It is in the plane which is perpendicular to A and B. So if A is here, B is here, A cross B will be perpendicular to the plane containing A and B. Okay, very, very important. So direction also we got, magnitude also we got, sir. Why the unit vector is perpendicular to the plane of the cross product, the two vectors, and what it means? Okay, see, when you get, sir, the vector is perpendicular to the plane, sir, how did it even happen? Like R was here, sir, F was here, you're saying R cross F is here? Oh my God. So what happens is, in reality, there are many such quantities in circular motion and other times that you need a straight line to get the direction. For example, if I tell you something is rotating anti-clockwise, next time it is rotating clockwise. For you, this is clock. For you, this is anti-clock. I cannot draw a round thing as a vector. I cannot draw a round thing as a vector quantity, number one. Number two, For you, this might be clockwise, this will be anti-clockwise. But for the person behind the board, this might be anti-clockwise, this will be clockwise for him. For a person standing on the top, he will not understand what is clock and anti-clock unless you tell, oh, if you are in front this side, then that is clock. If you are behind, then it is anti-clock. But what is front, what is back, that definition becomes very unclear. That is not how mathematics works. Things have to be very absolutely clear when we say what is the direction. It should be very uniquely represented. First thing, many rotational things are curved, so we cannot have curved vector. Second thing, anti-clock, clock, and the sense of happening is not so clear. So we said that if you take the fingers of your right hand and you curl it along that direction, automatically the thumb will come here. Oh, so that thumb is that vector. So that thumb is that vector. So say for example, I tell you, place your thumb in I cap plus j cap. Okay, I cap is here, sir. J cap is here, sir. I cap plus j cap means here. So place your thumb in this direction. Automatically your fingers will curl like this. So you know now the thing is rotating in this direction. The moment you place your thumb, there is a very unique way in which it will rotate. So we convert a curved quantity into a straight vector-like quantity using this logic. That's why you will see right hand thumb rule coming into play, which is, by curling your fingers. But the curling can be clock or anti-clock, same time. But to get it uniquely, you curl the fingers, the thumb will always uniquely point in a particular direction. Is this absolutely clear, everyone? Okay, beautiful concept which is there. Great. But you should know one thing. You should know one thing. The direction of the cross product. If you do A cross B, if it is up, see, A is this way, B is this way. A cross B will go up. But if you do B first and then A, thumb will point down. Yeah, thumb will point down. So you should know this definitely, that A cross B is not the same as B cross A, but magnitude wise it is the same, direction wise opposite. So can I say that it is not commutative? Not commutative. It is not commutative in nature. Yeah, it is not commutative in nature. Is this clear? A cross B and B cross A are two different things. Okay, everyone? Absolutely clear? Okay, perfect. Another thing, common mistake which many students do in the exam hall. You are writing and you have to do cross product. A cross B, okay, like this, A is here, B is here, okay, A cross B is here. You forget that you are using your right hand for writing purposes. Many of you might be righties, some of you might be lefties. So, then you might be doing the cross product using the left hand. If you do left hand, you'll get a completely different answer, opposite in direction. So be careful, be mindful. This is just a silly mistake which many students do while using the right hand thumb rule. Always use your right hand. In the exam, since you're already using your right hand for writing, many of you might have to be a little bit careful. Okay. Now, that we are clear about this, what are the different properties, sir, of cross product? Let's come to that, and also some rules also. Okay, what are the different things that we need to keep in mind? All right, so let's say we do A bar cross A bar. Let's see how many of you can get this. A bar cross A bar. Well, if you look at the magnitude of A cross A, magnitude of A cross A, it will be magnitude of A into sine of angle between them. Sine of 0 is 0, so it should be 0 because sine 0 is 0. So 100% it will be a null vector. Not just this, even if I do any unit vector cross unit with itself, it will be a null vector. Not just any null vector, sorry, not just any unit vector, even our specific vectors like I cross I or J cross J or K cross K, all of them will be 0. This is exactly opposite in dot product. Here, cross product with itself is 0. If you go back to our dot product, if you go back to our dot product, I dot I, J dot J was all 1. Look over here. All of them were 1. Here it is exactly 0. So keep that in mind. Okay, perfect. But what if they are perpendicular, sir? Oh, definitely it is not 0. In fact, what will be I cross J? What will be J cross K? What will be K cross I? What will be J cross I? What will be K cross J? What will be I cross K? So what is the answer for everything? I'll tell you very simply. Whichever variable is not there, first put that variable. In each case, can you see, like over here, I and J are there, K is not there. J and K is there, I is not there. K and I is there, J is not there. J and I is there, K is not there. KJ is there, I is not there. IK is there, J is not there. First put that variable. Till this point clear? But there is a sign associated with it. What is the sign? Observe. Just like the hands of your clock, sorry, the normal wall clock which is there, okay, which is like 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, okay. So go clockwise, like I, then J, and then K. If you go clockwise, if you go clockwise, then the answers are positive. If you go anti-clockwise, if you go anti-clockwise, the answers are negative. Simple. For example, I into J. I into J is clockwise, so 100% it will be positive. J into K. J into K is also clockwise, so answer will be positive. K into I. K into I is from K, I'm going to I. Closest. Don't say, sir, K to I can go like this also. No, go closest, man. So K into I, I'm going clockwise. So that is also positive. But if you see over here, J into I, J, I, it is anti-clockwise, so negative. K into J is anti-clockwise, negative. I into K is again going to be negative. Is this clear? Very easy way to remember it if you think clockwise and anti-clockwise. I'm so happy, SK Jyotidam, you got 99.7 percentile in the January attempt. And I remember those days. Oh my God, I'm so proud of you, Jonathan. And I'm pretty sure you will be leading, in some of those NITs, maybe in your favorite branch at 99.7. Definitely a great percentile to be at. Perfect. I would really be happy to know finally which branch and college you got after the counseling is over. Maybe you might be waiting for some stray rounds, but pretty sure you will get one of the best colleges and do well and enjoy your college life. Yeah. Sir, this is cool, sir. Sir, are there some more properties that I should be aware of? Yes. Before going to problems, there is one last property which I need to tell you, and that is your distributive property. Just like in dot product, we can distribute things. That means A cross B plus C. If I add two vectors and multiply, I have to multiply them separately, A cross B and A cross C, and then I can add them. That is also fine. So I can distribute A with B and C. This property is your distributive property. Okay, perfect. So this property is definitely followed, but commutativeness is not followed. It is not commutative. Please keep this in mind. Okay. Other things I have told you over here. So let's do some questions for cross product. Okay, let's do some questions for cross product. Say for example, these are your examples. Come on. Do 2i cap cross 5i cap minus 7k cap cross minus 2k cap. How much will this be? Then 2 I cap cross 3 j cap, j cap cross 5 k cap, minus, or let's say minus 2 k cap cross 4 I cap. How much will it be? Okay. So let's try to do these simple things. Very easy to find out. Same direction, I into I is 0. I just told it to you over here. I into I, j into j, k into k is 0. So 100% this first answer will be nothing but 0. Second answer, k and k. K and k same direction, right? Perfectly. Answer is 0. Gone. So first two things gone, 0 and 0. Let's do this. I into j. First of all, let's think simple numbers, 2 into 3. 2 into 3. That is one thing. And I into j. I into j means I, j, k. Oh, positive k. So it will be nothing but positive k cap. So hence it will be plus 6 k cap, or just I can put 6 k cap. It is one and the same thing. 6 k cap should be the answer. Lot of students are forgetting to write k cap or j cap. So be careful. Magnitudes is one thing. That is okay till dot product, which is a scalar. This is vector. So you need to give the direction also. Okay. Outcome is a vector. J into k. Okay. First of all, 1 into 5. 1 into 5 is there. Okay. K and j. I, j, k. Clockwise only. So it should be positive I cap. If j and k is there, I cap was not there. So this will be 5 I cap. Next thing. Minus 2 into 4. Let's do. Minus 2 into 4 is there. K is there. I is there. That means j is not there. K into I. K, I, j, k. K into I. K into I clockwise only, positive. So it will be positive j cap. So this will be minus 8 j cap. Just check this out. Minus 8 j cap. Yeah. So many students forget that I, j, k. So be very careful. Sir, let's do more difficult questions, sir. Okay. Say for example, you have 2 I cap plus k cap cross producted with 5 I cap plus j cap minus k cap. Okay. What will you do? Obviously open up and do all the multiplications, like you will have 2 I cap cross 5 I cap plus 2 I cap plus, sorry, 2 I cap cross j cap plus 2 I cap cross minus k cap plus k cap with 5 I cap plus k cap with j cap plus k cap with minus k cap. Out of these, k cannot be multiplied with k, answer will be 0. I cannot be multiplied with I, the answer will be 0. So only few of the terms are left out. I into I, j into j, k into k is gone. This is 2 into 1, 2 into 1. I into j. What is I into j? If you have forgotten, no issues. I, j and k. This is positive. This is negative. Keep that in mind. Okay. Now do it. I into j. I into j clockwise. So it is positive k cap. Okay. 2 into minus 1 we have. 2 into minus 1 we have. I into k. I into k is anti-clockwise. So it will be negative j cap. Okay. Is this clear? 2i into minus k. I into k is anti-clockwise. So negative j cap will come for this guy. What about this? Okay. What is there? 1 into 5. So 1 into 5 is there. K into I. K into I is clockwise. So positive j cap. That is for this guy. Last thing, k into j. K into j means anti-clockwise. So it will be negative I cap. Negative I cap. So this is going to be 2k cap plus 2j cap plus 5j cap minus I cap. So 2 plus 5 is 7. So 2k cap plus 7j cap minus I cap. But usually you put I first. So therefore it will be negative 1 I cap plus 7j cap, j second. And lastly you will put k. So 2k cap. So this is the final answer. This is the final answer. Hi Srinav. Yep. Good evening, cutie pie. Okay. Sir, but this is so lengthy, sir. I mean, look at this, no, sir, so much. And luckily here, two things were there. What if three things were there? Sir, it is so much of waste of time, sir. Teach some easy tricks, sir. Hold on, I'll teach you one easy trick. And that is by using, determinants. Okay? Just like you solved determinants, some of you might have learned this in maths. If you have not learned, don't worry. Forget the word determinants, just remember the technique. So say for example, you have to do A is, let's say, 2i cap plus 3j cap minus k cap, and B vector is 5i cap minus j cap plus 2k cap. Okay, and you have been asked what is A cross B equal to. You have been asked what is A cross B equal to. What is the first step? Observe carefully, guys. Okay, first write down I cap, then write down j cap, then put k cap over here. Leave two lines, put a line like this, but this time write I cap, put some brackets, but put minus j cap with some brackets. Lastly, put positive k cap. Okay, plus I, minus j, and plus k. Is this clear? After leaving two lines, put this. Why, sir, only minus with j? Why impartiality with k? Don't ask such questions. That is how you solve determinants. When you learn determinants, you will understand it. But for now, okay, just put it like this. Then, next step, just write down those numbers which are over here below I, j, and k. And in order, A cross B is asked. So first A, 2, 3, and minus 1. So I cap is 2, J cap is 3, K cap is minus 1. Then comes B. So that will be 5, then minus 1, and then 2. If it was B cross A, then B will come in the first line, then A will come in the last line. Okay, this is the second step. Everybody clear till this point? So whenever you have to do cross product of big vectors, okay, first put ijk and then put I minus j minus plus k in the after leaving two lines. Now in these spaces, just put those numbers which are with I, j, and k with a and b, okay, of each vectors a and b. All right. This is how basically you solve those determinants. Now, what is the third step? Observe this carefully. You might have, your teacher might have corrected your question paper, answer sheet, whatever. She will give correct or wrong, whatever. So when there is a wrong answer, what they do? They give it like this, no? They give a wrong like this, or maybe a wrong like this. That's exactly what you need to do over here. So you think of a wrong like a fish, like this. Think of the wrong like a fish over here, like this. Yeah, a wrong like this. You start like that, go like this, and you have to go with the same order over here also. How? I will tell you. When you want to find the first bracket, let's say for I cap, ignore this and ignore this. Ignore this and ignore this. You are left with this. Just go like this. Just go like this, guys. Yes, just like this wrong. Like this. When you go like this, multiply these two. 3 twos are, 3 twos are how much? 6. When you again go like that, cross, minus 1 into minus 1 is plus 1. And now just subtract them. So when you want to find I cap, forget this column, forget this row. These numbers which are there, go like how your teacher gives you wrong. So 3 twos are 6, minus 1 into minus 1 is plus 1. So 6 minus 1. Next step, observe this carefully. Okay. For J cap, forget this and forget this. For J cap, basically just forget this and forget this again. Okay. Just these numbers. That's all. So what will you do? 2 into 2, 2 into 2 is nothing but 4. Minus 1 into 5, 2 into 2, minus 1 into 5 is nothing but minus 5. And put a minus sign over here. For K cap, similarly, forget this column, forget this row, just concentrate on these numbers. So 2 into minus 1 is minus 2, 3 into 5 is 15, and just subtract them. 2 into minus 1, minus 2, 3 into 5 is 15. Okay, and just always subtract them. Now the next step is just solving them. What is 6 minus 1? What is 6 minus 1? That is nothing but 5. 4 plus 5 is 9. So minus 9 j cap. And this is minus 17 k cap. That is your answer. That is your answer, guys. Got it? Isn't it simple with determinant method? Once you get used to these, solve some 4-5 questions. I'm not even asking you to solve 40 questions. 4-5 questions, you'll get the hang of it. It's a very laddu type of solution. Yeah? Clear? Great, sir. I understood it, sir. So let's do some questions, sir. Okay, let's see. A vector is along the positive y-axis. And if the vector product with another vector is 0, then F2 could be, come on, think about it. Vector F1 is along the positive y-axis. So F1 bar will be some, I don't know, some number, let's say A. It is along the positive y-axis, that means A j cap. If its vector product with another vector is 0, so if F1 cross F2 is 0, it could mean one of these things. Either sine 0 is 0, or even sine of 180 is also 0. Therefore, F1 and F2 are parallel or anti-parallel or anti-parallel or anti-parallel. So that means F2 will be along y or negative y. But whatever it is, F2 will be some constant into j cap. B can be positive or negative, anything. It will be definitely along j cap. So I think it can be only A. These are along some other direction. So hence the answer will be option A. Is this absolutely clear, everyone? Very good, Rama. Perfecto. Amazing. Amazing. Next question coming up on your screen. A vector quantity says that A magnitude is non-zero constant. Which of the following expression is true for A? A magnitude is not zero. So which of the following is true for the vector A? A dot A is 0 always. A cross A is less than 0. A cross A is 0. A cross A is more than 0. We just saw it some time back. When you take vector A dot producted with itself, it is A cos 0. Cos 0 is 1. So it will be A square. So it can't be A. This does not make sense, inequality. But when you do A cross A, the answer is always 0 because sine of 0 is 0. So option C should be the most appropriate answer. Is that right? So cross producted with itself, the answer is 0. Dot producted with itself, the answer is not 0. It is in fact the magnitude's square. The magnitude's square. Perfect. Let me just give you more questions over here coming up on your screen. Okay. Let's say torque, this is an example. Let's say torque is R cross F and position R is given by I cap minus 2j cap plus 5k cap, and force is given by 2i cap plus j cap plus k cap. Question is find the torque. Question is, can you find the value of the torque? Okay, definitely we can. These are big vectors. So I'll start by our determinant method. So where you first write down I cap, then you put j cap, and then you put k cap. Leave two lines, put a big line, and you put I cap with a bracket, put minus with a bracket and j cap, and bracket of plus k cap. This is the next step. Next step after this, just start putting below ijk the individual components. For R it is 1, then minus 2, and then plus 5. For force it is 2, 1, 1. 2, 1, 1. That is your next step. Okay, this is also done, sir. Now for I cap, forget this column, forget this row. Minus 2 into 1. Sorry, minus 2. Array, what is this? Minus 2 into 1 and 5 into 1. So, yeah, minus 2 into 1 is minus 2 and 5 into 1 is basically 5. So, minus of that. For J, forget this column, forget this row. 1 into 1 is 1. 5 into 2 is basically 10. So, put a minus sign. For K cap, forget this column, forget this row. 1 into 1 is 1. Minus 2 into 2 is minus 4 and put a minus sign over here. Okay. So what will this be? Therefore, torque will be equal to, this is minus 7 I cap. 1 minus 10 is minus 9. So it will become plus 9 J cap. And minus minus is plus. So plus 5 K cap. So that is the torque. That is the torque vector over here. So if you know whose multiplication is it and individual vectors you know, using this determinant method, you can easily get the answer. Everyone? Yeah? Just see if you are getting this. Solve more questions, you will 100%, get a hang of it. Next question coming up on your screen. Which of the following is, mathematically correct or wrong? Correct or wrong? Okay. Which of the following is mathematically correct or wrong? A vector dot B bar plus C bar. A vector cross B plus C bar. A dot B dot C. A dot B cross C. A cross B dot C. A cross B cross C. A cross B plus C. A dot B plus C. A dot B B bar. A cross B. This is C bar. And there is C bar here without any multiplication symbol. So many expressions are given which is mathematically wrong to write down or which is mathematically fine to write down. Legal versus illegal. Okay. Yes, so we were minus 7 plus 9 plus 5. Is that what the answer that we got? For the previous one, minus 7 plus 9 plus 5. Yes, we got the same answer. Perfect. Okay, let's see which of the following is mathematically correct or wrong. Let's start with the correct ones first. I take a vector, add it with a vector. This is also a vector. Vector dot producted with a vector is perfectly fine. Nothing wrong with it. This is fine. I take a vector multiplied with a vector, I'll get a vector. Vector multiplied by a vector, yeah, perfectly fine. I can do that. It is allowed. What about this? Vector dot product with a vector. Dot means it's a scalar number. Scalar dot a vector is illegal. Whenever I have a dot symbol, this should be a vector, this should be a vector. Whenever I have dot, this is a vector, this is a scalar, this is illegal, guys. So 100% that is wrong to write it down. So this is wrong. Dot product, this should have been a vector, not a scalar number. Okay. Right? Sir, unit vector is only to know the, yeah, kind of, Rama. Yeah. What about this? I have a vector, cross vector, it will be a vector. Vector dot with a vector, that is perfectly fine. So there is nothing wrong in it. This is allowed. This will give me a scalar number. Scalar cross with a vector is illegal. Whenever I have a cross, this and this both should be vectors. So this is illegal to write it down. Got wrong. Okay, that is illegal. Vector into vector, a vector. Vector into another vector, that is perfectly fine. Nothing wrong with it. I will put a correct mark. What about this? A cross B is a vector. Vector added with another vector, perfectly fine. I can do that. But vector dot with a vector, it's a scalar number. Scalar can't be added with a vector. It is illegal. It is not right mathematically. This A dot B may be a number. It's a scalar number. Scalar C bar. Perfectly fine. Nothing wrong with it. This is like saying, imagine A dot B is 3. So it is like saying 3 C bar. 3 C bar means C bar, C bar, C bar. So that is 3 C bar. Scalar multiple types. So that is perfectly fine. Nothing wrong with it. But this one is 100% wrong because A cross B could be a vector. Maybe it is 5 I cap. Maybe let's say A cross B. Chuma, I'm saying it is 5 I cap. And C bar is some vector. So how can I write 5 I cap C bar without a symbol? What is that symbol over here? What is that symbol between them? There is no symbol. It is illegal to write it without a symbol. Two vectors can't be just written down adjacent to each other. I cap, J cap. It is illegal. I can write I cross J. This is fine. This is wrong. I can write I dot J. This is also fine. But I can also write 5 into J. This is also fine. But I can't write 5 I cap J cap. What is 5 I cap J cap? What is the meaning of it? It has no meaning. So therefore, that is 100% wrong, guys. Is this clear? Which is mathematically correct, which is mathematically wrong? Okay. Yeah. I'm back, received HCY and started solving. Very good. How to approach it? HC Verma, first read theory, then short answers, then objective 1, then go to solved examples, then go to objective 2, and then go to exercise sequentially. That is the right order of going through HC Verma. All right. Let's see if you guys can do this question. If A and B are two vectors satisfying the relation A dot B is magnitude of A cross B, then can you find the value of A bar minus B bar? Very nice. If A dot B is A cross B, A dot B means it is AB cos theta. A cross B magnitude means it is AB sin theta. AB cancels, so cos theta is sin theta. That is only true for one angle when theta is basically 45 degrees or pi by 4 radian. Perfect. So now we have been tasked with what is A bar minus B bar's magnitude. This is vector subtraction. Vector subtraction is nothing but first vector square plus second vector square minus 2ab cos of angle between them. So this will be nothing but a square plus b square minus 2ab. Theta is 45, cos 45 is 1 by root 2. So this will be nothing but root of a square plus b square. 2 and root 2 will cancel. It will become root 2 on the top minus root 2 ab, which is nothing but option number C, of course. Is this absolutely clear? We have used vector subtraction formula, vector multiplication for dot and cross. So three formulas in the same question. This was your JEE Mains 2022. So three formulas. Yeah, three formulas in the same question. Wow. Now let's do this particular question, guys. This is also very interesting. If three vectors A, B, C are coplanar, then their scalar triple product is how much? First of all, what is scalar triple product? Triple means 3, and yes, 1, 2, 3. Scalar triple means the outcome is a scalar, and that can only happen like this. A, B, you basically cross multiply, and then take the dot product with that vector. The answer will be a scalar. That is why it is called scalar three numbers product, scalar triple product. Vector triple product means you take a vector with another vector, cross it, and again cross it, then the answer will be a vector. That will be called vector triple product. Obviously, when you multiply three vectors, the answer will be a scalar or a vector. If the answer is a scalar, scalar triple. If the answer is a vector, vector triple. Logic is simple. Okay, fine, sir. So this is a scalar triple product. What is the scalar triple product going to be if they are coplanar vectors? Fine. Let's visualize a plane first. Imagine a plane. Something like this. imagine this is a plane. Okay. In that, let's consider three vectors. Let's say this is vector A. Let's say this is vector B. Okay. And let's say this is vector C somewhere here or here. It doesn't matter. Okay. This is, let's say, vector C. So this is vector A, this is vector B, and this is vector C. They're all coplanar vectors. That means they are in the same plane. Okay. Now observe this. If I do A cross B, take your right hand, four fingers, A cross B. A cross B will be nothing but this particular vector like this. Yeah, this will be that vector. A cross B. It will not only be perpendicular to B, it will also be perpendicular to A also. Not just that, it will also be perpendicular to C also. It will be perpendicular to the entire plane. So A cross B is perpendicular to the plane itself, is perpendicular to the plane itself, plane of A bar, B bar, and C bar. The plane of A bar, C bar, and B bar. Okay. Now, if you take A cross B, dot product it with a vector C, we know that these two are perpendicular to each other. A cross B is perpendicular to C. So what will happen when the vectors are mutually perpendicular? Their dot product will always be a null vector, or basically a zero vector. That means their scalar triple product will be zero. Therefore, their scalar triple product, is zero. That is the answer. So whenever three vectors are coplanar, you will see their scalar triple product is zero. That is also a coplanarity test. Okay, very interesting. Perfect. All right. So we have a final question, which is your homework question. Please solve it as your homework. It is not that difficult. This is your homework. Answer should be there in the comments. I want your answer in the comment section, just like the previous session. Three vectors are there. If A dot B cross C, this is scalar triple product, is 0, then what is the value of X? I'll give you a hint. First do B cross C. That means B into C. By how? Determinant application. I, J, K, leave two lines. Do that. Then do the dot product with A. Dot product is simple. Answer will be 0. Solving for that equation, you will get the value of X. Do it step by step. First do the brackets part. Then do the dot product with A. Doing dot product is simple. AX, BX plus AY, BY plus AZ, BZ. Just find it, you will get the value of X. That is coplanarity. Okay. Answer is there on the next slide, including the solutions. And let me also show you the last lectures, students who have solved our questions and everything. We did vector addition and subtraction, and it was a beautiful class. Smash that like button of every session that you are watching. Okay. And also subscribe to the channel. That is also very important, my dear warriors. PDF will be there in the description box after some time. You can see in the comments also it is pinned. A lot of students do comment and solve these questions regularly. Some students are hesitant, thinking, what if my answer is wrong? Don't think like that. Even if it is wrong, other students of our community help you. And that is the best part. Nobody judges anybody over here. We are all here to help each other out. Okay. So very good, Thiru. Very good, Gautam and Sulochana and Ramu. Thank you so much. Glad you enjoyed this session. And also make sure that this session also you're liking and commenting the answers of the homework question. You want to be a part of any of these batches where I am teaching, my lectures are there, or all our best teachers are there. The links are there in the description box. And if you're an 11th standard student, 100% you should be a part of the pro batches, which is an online batch where you get the feeling of an offline. And all the rankers which I showed you at the start, they are from our pro batches. Yeah. And Nothing better than booking a demo slot. So let's say, for example, sir, I want to know what is this pro batch all about. Just book a demo slot. It's absolutely free. No hard and fast things that, okay, you have to join. Just see how the demo lectures are. So enter your name, grade, etc., which board, etc., target, and you will get a call from our academic counselor, and they will help you and guide you to understand what is Vedantu Pro all about. Right from personalized attention to the best teachers in the country, right at the comfort of your home at an affordable price with heavy discounts, because the batches for the next 2 years and the 1 year are, starting. That will be probably one of the last few batches which will be there. So I want you to take the full advantage of it. Okay. So make sure you're filling up that particular form out there, and, be regular. Thank you so much, guys. I hope you guys had a great time. Vivant, Rama, thank you so much. Hi, Abhijit. Yes, thank you. Glad you guys made it through the session, and have a great time and keep studying. Very good, Tharuna. Bye bye. Take care. See you next time.